Rolling. How much time we got? Hold on. 3 hours. What you do? All right, everybody, we're ready. Welcome to Corporate Light again, and lighting part 2. I got a really good friend here who's worked with Corporate Light for many years. Started off as an intern here, and became a real lighting guy.
I don't know about that.
So I'll let him tell you about himself, but don't get mad at him. He's a Calvin boy. So.
Yep.
But we all believe in the same God. So. All right, I'll let you take it, Calvin.
All right. Frank, thanks for having me. I guess first of all, a little bit about me. So my name is Colin Gasink. I am a lighting guy. Nice picture, Charlie. You took that. So I'm a kind of semi-lighting guy. It's actually not my full-time job. I'm a freelancer. I get out into the industry when I can, but I don't spend all day every day. I graduated Calvin in 2016, so not that long ago. My degree is actually in computer science and then media production. So Calvin didn't have a program like Cornerstone does in kind of the live event side or even the audio side. So this was the closest thing. My full-time day job, I'm actually an application engineer at Steelcase. So I go work at Steelcase from 9 to 5. And then when time allows, I get into the industry, work live events at various places. Here, Calvin, I work some events and just in and around town. I would say I started out as a lighting tech, but I do a lot of other things too. I dabble in video, I dabble in audio. I think lighting's probably my passion to begin with, but just to say, you guys don't have to specialize in one industry or one section. Well-rounded individuals definitely help and go places. And all that to say too, this doesn't have to be your full-time job. I do it as a hobby, I do it as a second source of income, and I do it because I like doing it. That's a little weird. They're going nuts on me. All right, so just a quick agenda. Here's some topics that we'll talk about. I'll try and keep it practical. I'll try and keep it relevant. And then I intend at the end I'll run through kind of the theory, the educational stuff, I'll call it, and then we'll move into playing around with some of the toys, the console, and actually getting our hands into the lighting boards, lighting consoles. If at any point you have questions, shout them out, raise your hand. Can be interactive. We don't have to wait until the end. Whatever you guys are wondering, whatever you guys have questions about, just feel free to shoot them out. All right, so the first kind of job or first kind of function of lighting guys or lighting industry is rigging. So I think Frank said you'll cover rigging in more depth later on in the semester, but you can't really have a full rounded lighting background without knowing something about rigging. I'm by no means an expert, but I know enough to do it safely, know when to ask for help, and get lights in the air. So if you look behind me, we have a truss of, or behind you, sorry, we have a truss full of lights. Lights go in the air typically. You go to a big concert, right? There's hundreds, if not thousands of lights hanging from the ceiling. It all starts with rigging. I'll say rigging and power, and we'll cover power in just a sec. But there's a couple main components of rigging. You have motors. So if you look on each side of that truss, there's two black oval things, I guess. Those are motors. And and we can actually demonstrate what those do in a minute. Those hang to the ceiling, they drop down, and then you attach them to the truss. So that truss is another main component. That truss is the silver piece that the lights are hanging off of. And then there's various different types of truss. There's various configurations of truss, circle truss, wavy truss. Sky's the limit pretty much. I've seen people do some pretty cool things with that. So this is just kind of a simple setup, but if you take this on a grander scale, if you go to a concert or if you go to any event where they have fixtures or motors in the air, this is how it all starts. So when we start, they'll be all the way down at the ground. Something's going on. All right, so at the very beginning of the day, there'll be a crew that will go into a stadium or go into a ballroom, and they'll hang what are called points. And points are basically just the chain going up into the air. Sometimes venues will actually have hooks that you can hook them into. Other times you're just wrapping cable around a beam. Various different ways of doing that, various different ways of getting points where you need them. And there's all sorts of math that goes into it. We're not going to go into that, but there's people that do it for a living. Basically figure out how to safely fly whatever you want in the air. So it goes for audio speakers, it goes for lighting rigs, it goes for any sort of equipment that goes in the air. So Frank's bringing some of the equipment that does go in the air. So those are called shackles. Those are kind of the connecting the building blocks of it. The steel piece you can hear referred to as a dog bone. That will just extend a chain or various different ways of doing it. You actually wrap that around a beam if you want to hang something. And then we're also passing around the span set, and that span set's kind of that rigid loop with a cloth around it. And you can actually you can attach the truss with the span set. You'll see that done often. Here we've done special truss blocks that are pretty nifty. They just kind of clamp right in and connect to the motor.
And we are using a span set up there at the steel.
Yep.
It's important, there's two types of span sets. You have a steel span set, also called GAC flex, and then you have nylon, which doesn't have any steel in it at all.
A quick thing about the motors. So motors obviously need power, electricity to go up. So here we do have a motor controller or a motor power distro. So you just plug power into it. There's special cable called P14 that go to each motors. Those are connected right here. And this supplies the motor with power. You'll typically see the cable just dropped off the end of the truss. If you go to like a concert, a big show, they do a pretty good job of hiding where the cable drops. And they actually have special trusses, special dedicated trusses just to hold cable. I said there's math that goes into it. There's a bunch of load calculation that goes into how safely you can hold a rig. Obviously, you don't want to put a ton of weight on a fragile point. So if you do ever find yourself in a situation where you're involved in that, there's various things that you want to be aware of. One, how much weight can the building hold? So typically the building will have on file the max load per point. You also want to be aware of how much weight the motor can hold. So these motors are 1/4 ton, so they can hold up to a 1/4 ton per piece. You don't want to go all the way up to the 1/4 ton. You don't want to push the limit. So if you're safely under that, that's no problem. They go all the way up to Frank, do you have 2-ton motors here? Or just 1-ton? You have half tons, quarter tons, 1-tons. Then obviously the truss too has a weight limit. Can't put too much on the truss. As fixtures get newer, they get more powerful, but also smaller, less weight. Manufacturers are figuring out how to condense all the electronics, all the things that are needed to make a light work into smaller, lighter fixtures. So that's becoming less and less of an issue. Back in the day, right, you had these massive lights that weighed a ton, and you had to be very careful about not overloading your truss. So then when everything's hung, ready to go, you'll move the truss out. And then obviously you want to bring it up all together. If you have multiple trusses, you got to plan out how you're going to bring it up.
Yeah, I heard that earlier, right?
I think that chain's a little spun. Yeah. Wonder if the bag's preventing it. All right, so this picture right here is just a demonstration of how a typical rigger would attach a point to a beam. So there's a steel span or a steel chain or steel dog bone that goes up over the beam, a shackle, another shackle, and then this could be your chain that goes down. The shackles, I have not heard them called B-rings. D-rings, not that either. They could be. Yeah. You, yeah, you will find. Right. All right, hopefully this works. I got a YouTube video that probably will explain it better than I can. Turn it down.
This video will be about the basics of rigging. It is always an interesting feat to see how it is done. I will give you a quick explanation how. A lot of people go see concerts and they see a large lighting rig in the air and don't understand how it got there. It's quite simple in theory. What happens at the beginning of any load-in for a concert venue is that the rigger will climb up to the steel structure of the building. They take an elevator or a ladder to get to the catwalk. Down here is where the truss gets built. The rigger will be up here. He will look at the structure of the beams and know what they are rated for. 500-pound load, 1,000-pound load, 2,000-pound load, or whatever it may be. It takes 2 riggers to get the job done. The guy in the air and the ground rigger. The ground rigger has a tough job because if this guy drops anything, it could knock him on the head. The ground worker is always wearing a hard hat and is responsible for the other workers in the area to say, "Hey, there's a guy above working, don't come near me." This rigger will tie off a rope and drop it all the way to the ground. The rigger will assemble his span sets and wire ropes and whatever he needs. 5-footers, 10-footers, 20-footers, and attach them to the bottom of the rope. This guy will pull everything up. Now he has all his stuff so he can securely build what is called a point. A concert rig can have 100 points. Some will have 6. Depends on the size of the venue, size of the lighting rig, size of the trussing rig. Now down here, the ground rigger has what is called a chain motor or a hoist. He prepares the motor. Everything requires power. There will be a motor distro attached to power. The rigger will again drop his rope to the ground. The ground rigger will attach that rope to the end of the chain. This motor will have, let's say, 75 feet of chain, which is heavy. This rigger will pull that chain and its hook all the way up. Now you can imagine this is hard work. They are pulling a lot of chain and they can't drop it. The chain comes up and they hook it into the point they built. Now that's hooked in. This motor has a hook underneath it as well. Now we plug that motor in, turn it on, and hit the up button. Every once in a while you'll hear a ground rigger yell, "Chain spill!" Chain gathered up too much and has fallen out of the basket and will come whipping out down to the ground. You don't want a chain falling. Now here is our truss. We attach this motor to the truss, and we also have another one here to attach to the truss with a chain going up to the point. This rig has 2 points, which means there's 2 places where the rigger has created a point to drop a rope to bring up a chain. Now you have these motors plugged into power. You turn it on and these motors start climbing. Now we can attach the lights. They lift the truss to about waist height or head height while it's on the ground here, and the lighting crew comes in and attaches all the fixtures and gives it the okay. The rigger will say, "Truss moving," and the truss starts moving wherever it will live for the show. And during the loadout, the process is the same, just in reverse. That is rigging in its basic form.
All right, so a little cheesy, but it probably explains it better than I could.
Today we are going to talk about a basic lighting system. Every lighting system is similar and usually
All right, Charlie, Frank, anything else on rigging of note? All right, I actually do have one more video. I forgot. So this is actually a time lapse of a load in. Charlie will like this. This is I don't remember what show, how long ago it was, but this is at the DeVos Convention Center. Wolverine. So 3 years ago, this is a big rig that corporate put in to DeVos Place for a week-long show for Wolverine. Bunch of lights, bunch of audio, bunch of video. This probably is the best example of rigging, though, that I could find. So.
by end of day. Yeah. It's a ceiling.
So that was a full day. There were probably 50 to 60 people. All that just to get a rig in the air.
The first 2-3 hours is just building the truck. Which each truck is only 4 volts, but when you're getting that much truck and safety and doing all that and the other, it's a lot of time.
And like Charlie said, before you send the rig in the air, you want to make sure everything works. So all the lights get plugged in. We like to turn them on, make sure that we have control of them. Ideally. It's a lot easier to fix something when it's on the ground than having to go up in the lift or bring the whole rig back to the ground.
And that's the same thing if you guys are doing like, if you're going to church and you got your lights. Well, check the lights before you put them up on the ground. Make sure they got the right address. Make sure they actually work properly. Make sure they're in the right phase. The light can run in a bunch of different phases, 22 channels, 12 channels, 6, 12, 8 channels, or whatever the light fixture is. Do all that on the ground, make sure it works, then install it. So you guys are, like, if you're at churches, you find gear, stuff like that. That's the difference between a lot of times here. Oh, yeah.
All right, anything else?
Yeah, that was it.
A lot of those concepts go for audio too. We keep our rig on the ground until we've component checked everything, make sure all the wires working, and of course, before anything goes above head level, we're going to check for any loose things, a shackle placed maybe on the truck by some dumb person. You know, once it goes up, you're in the world of hurting people if you're not safety conscious.
All right, power. So another big portion of lights is power. If you're ever on a show, I would say lighting is probably the most power consumption piece of it. And it's usually the lighting guys that have to deal with the power and give it to the audio guys and the video guys. It's also usually the lighting guys that have to make sure that we have enough power. Same kind of concepts as rigging. There's a lot of math and calculation that goes in prior to a show just to make sure that we can safely operate all the equipment that is needed to be operated. So if we talk about power distribution, there's a couple of concepts or a couple of ideas. In the entertainment industry, most often we use what's called three-phase power. So in your homes, in your apartments, typically that's a single phase. Once you get into bigger venues, and especially in the entertainment industry, it goes into three-phase power. What that basically means is that you have 3 legs of power. So we'll have a ground, make sure that you're grounded, a neutral, and then you have 3 hot legs of power. There's all kinds of theory behind it. I honestly don't understand it all myself, but knowing that there's 3 phases and they kind of operate adjacent to each other, that's what allows a lot of our equipment to run. So when you get this big equipment, and I don't know if Frank covered this with audio, you're not just going into Edison outlet jacks, plug wall strips, and plugging in lights. You need a bigger source of power, and that bigger source of power is typically company switches. So a lot of venues, a lot of different places will have 200 amp company switches, 400 amp company switches, basically the main power box.
Let me jump in there. They don't necessarily know what Edison is.
Right.
Edison is the plug that you see in your house walls. 110, power, and generally it's 15 or 20 amps in a commercial setting.
Right, so 110 volt. The company switches also typically are 110 to 208 volt. They can run anywhere in between that. So you'll see at the bottom here, it's a little small. This is where you plug in the big power cords. Those big power cords are called feeder. Feeder sucks. It's big, heavy, not fun to run, not fun to pull out. I typically try and avoid feeder at all costs. But as a lighting guy, you have to deal with it.
This is the light stuff. This is called number 4. This is stuff we like to run. And these are called cam locks, which you may have.
Yep.
Yep. Color coordinated. This is pretty standardized. Green's going to be ground, white's going to be neutral, and then your red, blue, black are hot.
The important thing to note there is make sure you plug in your ground and your neutral first, and then all of your hots. And then when you go to unplug it, it's the opposite. Unplug all of your hot legs first, and then ground, or then neutral, and then ground.
And why do you do that?
Make sure you don't get shocked.
You want to stay grounded as long as possible. You can keep that ground. So if any electrical, problem occurs, that power is going to hopefully go to the ground. And
So if you were to pull one out and it's hot and it shacks something out like a cage or metal thing, it's going to go back to where the power source is. And if that power source isn't grounded on the other end, you can have a massive power problem.
Also, don't plug in or unplug cam locks when the company switch is hot. So there's usually a big switch on the front or a knife switch. Make sure it's off when you plug all your power in, and make sure it's plugged into the receiving end before you flip that switch.
when he says cam locks, that's what we saw on those cables and our turbo phones.
But that'll give you an idea what that connection point looks like. And you'll find these cams on all thicknesses of cable. So it'll use the same plug, but the cable might be thicker or thinner depending on how much amperage you're running down the line.
Most of the time, if you're doing live events, you're not. You sometimes are in charge of that. But like if I show up on site, I show up with the cam locks and go, where do I plug them in? And there's like a master electrician there that will plug them in, turn it, be like, are you ready to go hot? You plug the other ends in, plug in whatever you want. You tell him when you want to go hot. He'll go hot. He'll probably lock it, or it'll be locked already, so they have to unlock it because it's a big switch. So usually you're not touching that end of it, but to know all of that, you got to know, because then they're going to come up to you like, are you hot? And you're like, yeah, sure. And then like your stuff's not plugged in, or you want to have. I like to have as much plugged in for when they hit that switch. It goes, my whole village is like powered up and all at once. So because then if something goes wrong, the master electrician is there, because usually sometimes they'll be like, all right, see you guys, and then he's back to flip the switch. He doesn't babysit the whole time. So.
Right. So the feeder on the other end plugs into this box typically. This is called a power distribution system or box, I guess. So on this end right here's the other ends of where you plug the feeder in. Think of this as basically a massive plug strip. Power comes in, and then you can plug various things into it on the other side. Each one's configured a little differently depending on what you're plugging in. You can see this one all has SACO outputs up here, and then L2130 outputs down below, and we'll get to that in a second. It also has your standard Edison plugs right there. We'll get there. We'll get there. So in the lighting world, I would say kind of there's two types of power. We typically call it non-dim and dim. Non-dim means not dimmable. So standard power, you plug all your moving lights into it, you plug LEDs into it. The other type of power is called dimmable. That takes kind of yet another, a different box. called a dimmer. Here's an example right here. There's not a whole lot to it on the front. It's all kind of internal. Charlie, if you flip back to the PowerPoint. The bottom left is also a dimmer. And this allows, with conventional fixtures, so fixtures with like a lamp, you can control the intensity of the light. So it can be 0% or it can be 100% or anywhere in between. It's not strictly an on-off. And we'll see that in a second. Dimmers work by basically metering the power. So taking the power, limiting the amount that goes through, and the rest of it gets dumped down the neutral leg. So in big rigs, big feeders, you'll often see 2 neutrals just to cover that load, cover that power that gets kind of dumped off that leg. So a little bit of theory. I have one somewhere. A little bit of theory. Ohm's law. Who's heard of Ohm's law? Perfect. A couple of you. So Ohm's law is an equation basically to determine power requirements, voltage requirements, amperage requirements, so on and so forth. So when we talk about power, and I gotta read my notes or else I'm gonna screw this up. So when you think about power, I like to think about it in terms of a water hose or a water pipe. So, right, you're connected to a faucet, you have a hose, and then the output. So if you think about the amount of water flowing through that pipe, that would be equivalent to your current. And that's your amps. The pipe itself is the conductor, so the means to get the power from point A to point B. And it's kind of also the, in some ways it's the resistance. So the bigger the pipe, the more power can flow through it. The smaller the pipe, the more resistance you're going to have, and the less voltage you'll get at the other end. And then if you kind of, or the less power you'll get at the other end. And then if you kind of think of a reservoir of water or the source of water, that would be your voltage. So Ohm's law basically says volts equals amps times ohms. So volts equals V equals I times R. Here is a little chart. I should have blown it up, but just with kind of the scientific description of what a volt is, what an amp is, what an ohm is. So volt is the potential difference across a 1 watt load with a current of 1 amp. Ignore current for a little bit because that is a super technical definition. Resistance is the amount of resistance that will produce a drop of 1 volt when 1 amp flows through it. And then power is 1 joule per second. So again, there's a whole bunch of math, a whole bunch of theory behind that. The important part to know is how not to overload a circuit, how not to plug too much into one circuit, one power. So if you look at that box, there's multiple circuits on it. Each one of the SOCO plugs has 6 circuits on it. So you can plug up to, on that box, 36 circuits of lights. There's 6 SOCO plugs, plus all the other types of connectors. So just as a quick example, if we think about how to do that calculation, We're going to do it in terms of power. So this fixture right here is a conventional fixture. If I take the lamp out, I can read on the lamp, and I'll pass it around too. It's a little, well, this is not a great example. Let me find a new one. Frank, where's your spare lamps?
Pretty in that little black case. You should see some.
This one?
Yeah.
No, that's a D-split.
There's a lamp.
Right here. Oh, there's your PMX. There we go.
It's everywhere.
Probably. So when I pass this around, just do me a favor, don't touch the actual glass. Keep your hands on the base. If you look at the writing, you'll see 575W.
Why don't you touch the glass?
We'll get there.
Oh, dude.
So don't touch the glass just because your hands have oils on it. If those oils heat up that glass, once the light turns on, it will explode. What? Exactly. Same concept. All right, Charlie, we're going to pull an audible.
What we doing, bud?
Can you do a GoPro?
My face freaking out. Oh, LED. Nah. Frame rate.
We'll talk about that on the video portion. Why is that?
A little bit like, what type of light?
No, P equals VI. All right, so right, the big thing to know is how not to blow up a circuit. So if I take a 575 watt bulb, I want to know how many lights I can plug into one single circuit. So the equation is P equals V times R, so power wattage equals voltage times amperage. So let's assume I'm running a 120 volt circuit at 20 amps. That's the right side of my equation. Sorry, this is upside down. Don't ask me to write upside down because I can't. So this right side of the equation is 2400. And then I want to know how many lights. I just divide the wattage divide 2400 by the wattage. And that is 4.17. So theoretically, I could get 4.17 lights. I'm going to round that down to 4. And probably just to be safe, I'm going to keep it at 3. There's power factors involved. There's resistance involved. I'm probably not going to get the full 120 volts at the end of that circuit. 4 I could probably do, but if I have the circuits, keep it safe at 3. On all the lights in all the manuals, even printed on the little stickers on the lights, you'll see information about that light. What voltage it runs at, what watt it consumes at max power, just idle power. you'll have all that information. PPT. All right. Anything else about power? Any questions? All right, the next big thing about lighting is control. So if I can power the lights, how do I control the lights? So we'll talk about DMX and then kind of the different lighting consoles. So let's kick it off with... Frank, I'm going to break your E6.
I've been thinking about trying that new all legume diet.
Hello and welcome.
All right, this one is super cheesy. I apologize, but it explains it.
My name is Chris. With the help of this marker board and these turkeys, I will be explaining the basics of DMX lighting in this video series. I'll give you an introduction to DMX, explain DMX addressing, I'll talk about dip switches, I'll touch on DMX wiring, and finally, I'll talk about some different methods for controlling lights with DMX. All right, let's get started. DMX stands for Multiplexing Data Transmission. It is the protocol used to control lighting equipment. Let's say we've got one light with one dimmer function. This function lets us control its brightness from 0 to 100%. Let's say the light is connected to a line and we can pass different numerical values to the light through that line with a control device. This light interprets the number 255 as full intensity and the number 0 as off. In part 5 of this series, I'll talk about how this control by numbers is useful. But let's keep going with our example. So let's say we've got 3 more of the same lights in the same controller. First, we must connect them in series. We still want to send values that will control brightness, but we want to control each light separately. So we give each light an address. Then we put a number between 0 and 255 in a package, and we give that package an address. Then the controller will send that package out to each light in the series. If that address matches the address on one of the lights, the package will be delivered to that light and its brightness will be adjusted according to the value in the package. You know, the value between 0 and 255. In reality, any given light will have more than one function. Each additional function will require its own unique address so that it can control that function independently. One single DMX cable can carry packages to 512 addresses. We say that a single DMX cable has 512 channels of control. All 512 channels create a network called a DMX universe. Large control desks or operator consoles that you might see at a concert have the ability to control multiple universes. There's DMX software that also has the ability to control multiple universes. So there's a basic introduction to DMX. I hope you stick around for the next video where we'll talk about how DMX addressing works. Also, be sure to check out uniquesquare.com for great prices on lights, DMX controllers, or any other pro audio gear you may need. If you have any questions, you can follow the link to our blog in the description below and leave those questions there. We'll answer them as soon.
All right. If you want to follow the link and get a great deal on lights or pro audio gear, go for it. So that's the basics of DMX. Basically a protocol used to control the lights. It goes back to bits. So in computer science, right, bits and bytes, 0 to 255. Each DMX channel has parameters from 0 to 255, and you can be at various ranges through that. So if you think of just a single light dimmer intensity, that dimmer can be on a curve from 0 to 255. So 255 would be at 100%, 0 would be at 0%. The more things that a light can do, the more intelligent the light, the more channels it can take up. I've seen lights that take up half a universe of DMX. So there's lights that really will take up to 300 channels of DMX. Then like you said, the DMX universe, 512 channels in a DMX universe. You have to address your lights accordingly, and we can talk about that as we get into it more and more. Just so you're aware, I won't go into them. There are other protocols. RDM is a DMX-like protocol that actually allows two-way communication between the light and the console. So typical DMX, you take a signal from the console and send it to the light. RDM allows that communication back down to the console. So the lights can tell the console information about the light itself. Statuses, so if there's an error message, if it's overheating, it can tell the console that it is overheating. You can also set the DMX address from the console itself. So typically you'll have to go to the light and punch in the address. With RDM, it allows you to basically give the fixture an ID, and it listens for that ID, and you can set the address with RDM. Good question. Then other protocols, so you'll hear things called out like ArtNet, MANet, ETCNet. Those are just different protocols each manufacturer has come up with to communicate with their consoles, with their lights. Really, at its foundation, the concepts are the same as DMX. Just with ArtNet, MANet, you're communicating over Ethernet instead of a copper DMX cable. Lighting consoles. So again, there's various shapes, sizes of lighting consoles. This is a Grand MA2. The one on the screen is actually the Grand MA. The Grand MA is the company name. It's their newest console, the Grand MA3. But there's all sorts of different manufacturers of lighting consoles. They all have their own lines, their own brands. ETC has their own line of consoles. Hog has a line of consoles. Leprechaun has consoles. At the end of the day, they all have different software. They all operate differently in terms of user interaction, user friendliness, how you interact with it. But at the end of the day, they're all sending out DMX or signals to control the lights.
Different consoles kind of run like Mac versus PC. So like somebody might be a master on the Grand MA and then go to like the Roadhog or ETC. It does the same stuff, DMX across the board, but it's not programmed the same way. It's not set up the same. It's literally like get it on a Mac and get it on a PC. Like if you know Mac really well, doesn't mean if somebody throws a PC, you know what you're doing. So it's kind of like that exact same concept. They're both laptops. They both do the same thing. Just how you get to them, completely different. So you run into people that are masters on MA, and then they throw down with the ETC console or Roadhog, and that's when like engineers like Colin that sit back and like, what do you need help with? I need this to do that. Colin shows up and he'll make it happen, and then they'll run it because the LDs know what they want. They just don't know how to get it. It's like I need my PowerPoint to do this, or I need my PC to do this. They know how to do it in a Mac, not in a PC. So that's kind of where different consoles come into play.
Right. So we have an MA here. This is a ETC Smart Fade ML. The GoPro. I'm not going to mess with it quite yet. I will say there is a little bit of a difference in consoles. You don't see it as much anymore, but as the moving lights, as the intelligent lights came on the market, there were different consoles for conventional fixtures versus intelligent fixtures. So you can't really plug in a 15-year-old lighting console and expect it to run a moving light. They just weren't that advanced at that time.
Do you guys get what like conventional fixtures versus intelligent ones are? you get like the down dirty. Okay, I was just wondering. I wasn't
Yep.
sure if that got covered.
It's coming up in a slide.
All right.
You'll also see consoles like this. So this is just a USB dongle with a DMX out. I can plug it into a laptop. There's a software program that will run on a laptop, but it will do the same thing as this will do. You're limited on universes here. You're limited on features. Yep, one universe. But in a pinch, these will work. Yep. Yeah, you could. You probably could run. Yeah, and that should be plenty. You probably could run multiple dongles. Could probably even run multiple different manufacturers on the same laptop. It would probably bog down and
Yeah, your
get
graphics
freaked
card would
out
have
a
to be
little
like
bit.
crazy to do that, and then yeah, you multiple universes get one per software. But if you like, he'll show you in a minute. What it looks like is you don't want to run more than one because one, it's going to make your laptop get slow, but your interface, you're like shrinking it. We're going to do like a split screen of a console that's already big. It's kind of yeah, it wouldn't do it.
Any other questions? All right, cabling. So with power, with rigging, with control in mind, now we're going to talk about how you actually cable, how you actually hook everything together. So there's really for lighting guys, two types of cabling, power cabling and control cabling. So in regards to power, there's feeder, right? We talked about feeder. There's the big feeders, that big, thick, heavy cable that plugs in with cam locks into the company switch and into the distro. Another type of cable is called SOCO, short for SOCAPEX. Don't ask me what it stands for, but that is this type of cable, and you'll often see this type of cable run from the power distro to a truss or to an area where lights are, and then from there they'll get broken out into this octopus looking thing. This plugs into the other end, and you basically have standard Edison on the other end. So each one of these tentacles is a circuit.
Or stage pin. I brought stage pin in that first week we talked about lighting.
Yep.
Find that more often in theater.
Yep. So SOCO can run both non-dim and dimmable power. You just got, when you have both on a show or when you're working in a venue with both, you just got to make sure that you clearly label it. You know which SOCO is dimmable and which one's not. If you go and plug in an intelligent fixture or a moving light into a dimmable circuit, it's going to do all sorts of weird things. So SOCO feeder twist lock is also another type of power. That's what the motor distro will run off of. You'll hear it called L2130 some places. What are other names for twist lock that you've heard? Or L2130.
L2130. Yeah. They used to call them Hubble connectors, but there's like several types, so it's kind of a generic term. But Hubble is kind of like Kleenexes to, tissue,
Right.
It's a company that makes these types of connectors.
There's a standard Edison, just the plugs that you guys are used to.
Can I throw one more thing in there about this cable here?
Absolutely.
Notice it has five connections. It's sending 3-phase power, so the very same kind of power that's coming into this unit, 3 hot legs, a neutral, and a ground. It's doing the same thing there.
Right. The blue and white one,
I got one right here.
oh, there you go. That's called PowerCon. Just another way of powering a light. Some lights take PowerCon power in.
Knowing what some of us know about audio, what does that look like? NL4. But try to plug it into an NL4 hole, it won't work because they have little notches and grooves in the right place that make it not able to be used as an NL4 cable. Yes.
In and out. On the light, the plugs are actually blue and white too, so you know which one's in, which one's out. Depends on, yeah, depends on the light, depends on the circuit.
That's a European, like that's made in European, right? European PowerCon is like a European start for road tours.
Yeah, probably.
It's made by Neutrik. I think Neutrik invented it. You know.
I will say, I think it's becoming more and more standard.
Yeah,
Uh,
that's
you-
the standard because it locks,
Yes.
and it's, yeah, it's just, it's pretty far more than that, isn't it?
So the lights that we have here, right, they're PowerCon connectors on the light, but then they're just converted into an Edison plug on the end. There's no reason why you can't go straight PowerCon in though, and daisy chain them back and forth.
And I have one of those, PowerCon to Edison. Remember Edison is what we tend to plug in our own homes. It's a very common plug. And here, not to interrupt too much there, Colin, but we have an Edison to stage pin.
Yep. Like Frank said, you'll see stage pin mostly in theaters. You'll see it out in entertainment or on the road, but not very often.
Edison is a universal power cable. Some people call it power cable, some people call it Edison, some people call it frog.
Or just a 110? I don't know.
110. That's not the whole list. Every show I do, I find some new type of power cable, it seems. Different companies use different things. Manufacturers use different things. Production companies use different things. Tours use different things. But knowing the basics, knowing kind of the look and feel of each type of cable will help. The second type of cable is control. So you're not sending power down this, but intelligent lights or lights need some way to talk to the console. And that's, the protocol is DMX, but you also hear the cable called DMX. There's two types of DMX, I'll say, 3-pin and 5-pin. The 5-pin can be used for RDM. The extra 2 pins are actually the RDM pins. The 3-pin cannot. But really, when it comes down to it, if you're not using RDM, they're using the same pins. It's just a matter of connector. You'll notice that the 3-pin looks a lot like an XLR in a pinch. Depending on the cable, depending on how it's wired, you can use them to be interchangeable, but it's not recommended. Only in a pinch.
Now, our lighting guy made all his 3-pin DMX. Well, no, but it's what kind of cables? AES.
Yep.
I don't know if he did that just to keep them separated because we don't like to use AES cable for standard XLR use, although they're the identical plug. Or is it special to lighting that they use AES cable?
I don't think so.
I think he did it to intentionally not get audio XLR mixed in with 3-pin DMX. And we labeled them, we painted the ends green, and it's his cable, and you know, it really discourages audio guys from touching his cables.
What? Probably should. You can also interchange between the two. So some lights have both 3-pin and 5-pin. There's also adapters that can translate 3-pin into 5-pin and vice versa. The other cable is just a standard Ethernet cable, or sometimes you'll hear it EtherCon. It's just an Ethernet cable with a kind of locking jack on it. Some lights will take that in as well. All right, so now we'll talk about fixtures. I'll try and go through these pretty quick because I do want to keep time for playing on the console. So when I talk about conventional fixtures, these are what I'll call your dumb fixtures, not very smart, basically just on, off. You can't do colors programmatically, you can't make them move. It's just a light inside the housing. So the first one, you'll hear theater term ellipsoidal. That's this. You'll also hear it called a Source 4. You'll hear it called a LECO. There's really a ton of different names for it. People all call it differently. ETC is kind of your main manufacturer of it. And really it's your typical stage theater light, your conventional light for stage washes, for theater work, basically your standard light. So parts of it, obviously there's a connector, there's a removable base where you can take this out, and this is what houses the lamp. So your lamp or your bulb is housed in the base. And this just screws in. On the back side of it, can't see it very well. This is a reflector, and all that is basically a mirror to intensify the light, to show, or to basically project it out. The middle section is kind of called your barrel, the barrel of the light. These tabs are called shutters, so you can focus and shape the light using this. Then there's adjustable lenses, and there's actually multiple different types of lenses. They are measured in degrees, so this is a 19-degree lens. And the degrees is basically the field angle, so how big the pool of light is going to be. It goes from, I think, 14 or so degrees up to, I've seen 75 degrees. I don't know the exact, but they're interchangeable here in this base.
Degrees go as far as where that light, how far away that light's being thrown. Because if it's a wide, like a 75, it's kind of like a fisheye. So it's gonna spread the light out real far. It's narrower, it's not gonna have as big an angle, so it can shoot farther. So a lighting designer also has to figure out how far to throw, just like a projectionist have to do the lensing. They have to figure out what lens angle they want as far as how far they're going. That's why you kind of take that in effect. You can rough it a little bit, but you've got to have a decent ratio of where you're throwing.
All right, this was working, but
So I would imagine there's probably a Easymatic chart that tells you how many feet a 19-degree space will fill at, what distance.
Well, it's kind of like a zoom lens on a camera. Like, oh, okay, 20 can get me 20 times, but how big is the object I'm shooting 20 times away? So that kind of varies, but you kind of know, like, what is it kind of like? I know if I'm doing 40 feet, I'm bringing the 19. well, we don't have 14, so maybe a 14 is optimal, but you kind of deal with what you got. But you know if you're really close, you're going to go wide. That's why usually we'll bring like a 26 and a 36 if it's farther, and a 19 and a 26 if it's closer. But I don't know of any kind of chart that it tells you, because you're never going to have, there's no universal stage size. So if my stage is large, but it's far away, there's going to be a different lens versus if it's small and it's still far away. So you've got to kind of just like do the cone of light, just like the cone of projection, and kind of just map it out per show. Because then what if I have 8 instead of 4? Well, I don't have to cover most of the stage because I have 8, so I have more to cover the stage. Versus 4, I need a little bit wider. So it's per show.
Well, I thought more like there's something like, say I take a source 4 like that, stand here and put it on the wall and let it be totally a circle. That is a formulaic idea. That circle's radius is going to be 3 feet. Take that lens out, put a 36 in, it's going to be 6 feet. You know, maybe there's a chart that kind of tells you that. Probably
There is.
somewhere. Yeah.
Yep.
Okay. Eyeball.
All right, this was working, but yeah, I don't know.
Well, you remember they were kind of whacking. I wonder if the DMX got half cocked or something.
Let's see if this will work.
You guys can stand up and stretch if you want. No, you're in here for 3 hours. Video is going to be a lot more fun. I'm going to move around. Y'all can still screen. Maybe I'm going to take the camera apart.
Make them build screens.
Yeah, I'm going to have them build this screen. I'm done. I'm PM now.
Yeah, let's take a break if we can.
Yeah. What do you need? What do you need, man? You got a bad DMX?
Maybe. Ready? It's thinking. All right, we'll figure that out later. All right, so now that this is working, right, there's different things that you can do with the light. These shutters allow you to basically chop off the light angle, so side to side, up and down. They are mirrored, so that's a little tricky, right? If I move this bottom one up, it actually takes out the top of the light. You can move the barrel in and out, so it will. What happened? Weird. It's the console. Something's freaking out. So you can adjust the focus of the light. So right now, this is a pretty hard focus, hard edge. You can move it in and out once it comes back. And soften the focus up, you'll hear it. So just connected to the surface. No, the computer. Not yet. Right, so you can just adjust the focus back and forth. That's about it for control on that. Obviously, you can move it around, position it in different ways. But you're pretty limited in terms of conventional fixtures. Other conventional fixtures are par cans. So here's a par can. It's just a big scoop of light for stage washes. You'll see this a lot in rock and roll and just general stage lighting. They are like workhorses. One thing I did forget to mention with the Source 4s, if you want to make them different colors, so any color under the sun you have to put these gels in them. So these are special filters that will color the light. Most typically in the stage setting, you'll just see this kind of bluish, and that's color correction. Whole bunch of gels.
Those are expensive. So if you use hydrogel, gels are expensive.
So the gel will go inside a gel frame, and then the gel frame can just get inserted into the light. Like so. There's no color gels. You'll hear them frost. That will just soften the light, make it less abrasive, a less abrasive look on the face. Gels are mostly to help the video guy out. So the video
Is that what a color correction is?
color correction will help the video guy.
Make people look not to watch out on stage. Black and white balance.
Yep. Other type of lights, so there's a par, there's a Fresnel. Again, just a big scoop light. You'll see Fresnels a lot in video. So live TV or video shoots, those are often used. Blinders, so this is an example of a blinder. These are crowd blinders. So right, you put them out, face them towards the crowd, rock and roll. When the crowd goes nuts, you shine lights on them. Exactly. And then spotlights. So we did pull a spot out. I'm not going to take it out of the case because it's just big, bulky, heavy. I think you know what a spotlight looks like, the bottom right. Those are typically operated by someone. So you have someone standing up in the catwalks or standing in the back on scaffolding, whatever, moving the light around, following the lead singer, following the
You're always last
superstar.
in line, aren't you?
Spotlights are not EMX.
They can be. Yep. So with all of these conventional fixtures, they get plugged into a dimmer, right? And the dimmer is what controls the on and off. So not a true example, but in this case, this bar acts as the dimmer. So there's a power source to the dimmer. The DMX gets plugged into the dimmer. And then this light's plugged in to the dimmable power. Same thing with that case right here. You would plug power into this box right from the feeder. The DMX would come from the console into this box. and then individual power cables to each of the lights would come out of this box. So the control, the on-off, is really happening at this box and not the light. All right, intelligent fixtures. So these are the fun ones. These are, you'll call them, you will hear them called intelligent fixtures, moving lights, other things. Again, people have different names for different terms. Again, various shapes, forms, sizes. The general categories, I would say, boil down into spot, beam, wash, hybrid, and then I'm going to add kind of just a unique one, so flash and trash. Just special, unique lightings that lighting manufacturers fill a unique niche with. So your spot fixtures kind of create that spot on stage. It's a pretty defined pool of light. Again, used for stage washes, used for effects. Your beam fixtures mostly are used for effects. They can get super narrow, so a super narrow, intense beam of light. You can also put gobos, you can put shapes into them, and we'll show that in just a sec. Hybrid fixtures are kind of just the mix between both. So some manufacturers will make a fixture where you can kind of bridge the gap, play on both sides of that line. Then like two in the bottom left, again, are kind of that unique niche category. There's not a real spot purpose, there's not a beam purpose, it's just a lighting effect. The strip lights that you see also could be one of those. So let's see if I can make these work. All right, so to start out with a wash, it is not working. Going to restart again and disconnect.